All right, so let's do 313. We're supposed to calculate V1 and V2 in the circuit of figure 3.62 using nodal analysis. So using nodal analysis. So using nodal analysis, we can figure out V1 here. Remember that Ohm's law, V equals IR. So if we call this I1 here coming down, we know that the V1 is equal to I1 times 50, IR. And if we want to rewrite this, I1 is also equal to V1 divided by 50. Okay, so that's just another way to write this. Now let's take a look at V2, this node 2 here. So we'll look at this entire node here. And we see that we have 15 coming in. Let's call this I2. And going out this direction, that must be I1. We have I1. So whatever flows out this way must also come down this way. So that's I1. So let's do KCL at 2. We're going to do KCL. So that's n minus out. I'm going to use n minus out equals 0. So coming in, we have 15. And going out, we have I2 and I1. And set those equal to 0. And we've I2 here can be written as V2 divided by 30. So let's make that substitution. So V2 divided by 30. V2 divided by 30. And I1, we already said, was V1 divided by 50. Right? That's this up here. And we set that equal to 0. Well, we really only have this equation here, and we have two unknowns in this equation. So how do we solve this? Well, it comes down to, let me erase some of this. So let's take a look. We have I1 going this way. I1 going this way. So there's a relationship between V2 and V1 here. And we have V2 plus 600, that's this, plus 600, would be at this point here, minus I1 times 10 equals V1. So that's this relationship right here. So V2 plus 600 plus or minus I1 times 10 equals V1. So this is an important relationship here. And remember, we can put in for I1, V1 divided by 50. So if we put that in, let's see, we have V2 plus 600 equals 1.2 V1. Okay, let's keep going. And let's see. We multiply this equation here by 150, I believe. Okay. Now we can, let's see, V2, 5/6, let me write that somewhere else. 5/6 V2 plus 500 equals V1. We should be able to put that into our V1 here. And solving now, let's see what that comes out to be. It looks like V2 is equal to 100 volts. Does that work out? And V1 is equal to 583.33 volts. So those are the two voltages we were looking for, and that is the solution to this problem.